Welcome to Prisma Interviews. Today, I'm really delighted to have two guests. We have Robert Craigie and Luca Steeb from the Prisma team. So let me first do a round of introductions. So Robert Craigie is a software developer who's been studying computer science at Dundee University in Scotland. He's been programming with Python for about 5 years now. And the Prisma Python Client, which we're going to discuss today, is the first open source project that he's released. And so in today's conversation, we hope to get better insights into the Python Prisma Client. And now our second guest today is Luca Steeb. Luca Steeb is a software engineer at Prisma, where he's been primarily working on the Go client that is currently available in early access. So now, without any further delay, I'd like to bring Luca and Robert to the stage. Welcome. It's nice to have you, Luca
Hello.
and Robert.
No.
Hello, nice to be here.
Nice to have you. Today we want to discuss the Prisma client for Python, right? And here I have the docs for it open, and I'd love to sort of open up with a question to you, Robert. What motivated you to write this Python client for Prisma?
Well, as I said, I've been using Python for a long time, and I only recently got into actually using types, because you don't need to use types in Python. It's all dynamic, and and there's basically nothing else like Prisma Client Python in Python. Like, there's no ORM that guarantees Typesafety or anything like that. So I thought I'd rise to the challenge and make that.
And have you used any other of ORMs in the Python ecosystem, like SQL Alchemy and the Django ORM?
Yeah, I've used SQL Alchemy and Django a little bit, but not that much, to be honest. I normally stick to just raw SQL queries before, to be honest. So it's a big change.
Okay, so you've gone from like raw SQL, you tried out a bit of SQL Alchemy and Python ORM, and then you sort of came across Prisma. What was sort of the motivation behind sort of, taking the ideas of Prisma? I guess you must have been impressed enough with Prisma using TypeScript to want to create a version of that for Python.
Yeah, I came across Prisma using Next.js and Next.js. That's how I found about Prisma. And then I was really impressed, basically. I liked that. It was also really readable, because lots of the Python ORMs, I don't think they're very readable for like complex queries, because you're just chaining lots of calls, and I didn't like that. So I like the way Prisma structured their queries a lot, I guess.
Do you think that it's changed your mind about using raw SQL?
Yeah, because when you use raw SQL, you don't have any Typesafety guarantees at all. You could write the completely wrong query, and you wouldn't realize until you'd executed it. And yeah.
I see. And tell me more about, how does Typesafety work with Python when you're using the Prisma Client Python, and even just more broadly, Typesafety in Python?
Yeah, so it's completely optional in Python. So there's no runtime guarantees at all. But there are tools that you can use to check types statically. So there's like Pyrite, which I use quite a lot, and so there's no. The types are hints, because at runtime they can be anything they want that you can pass whatever you want. It doesn't matter. But
is it fair to say that it's similar to JavaScript and TypeScript, like TypeScript being the types for JavaScript?
Yeah, that's a very good comparison.
Okay.
Yeah.
Okay, so essentially it's all optional, and then you have the tooling. What was the name of the tool that you mentioned that essentially allows you to run these compile time type checks?
Pyrite. That's a type checker. That's also what powers VS Code. So if you're using VS Code and use Python and it comes up with a red squiggly line, that's Pyrite telling you that.
Oh, I see. So it's very similar indeed to TypeScript. Luca, do you want to take on from here? You had so you've worked a lot on the Go client. You're still actively working on it. Maybe before you get into some of the questions, you could give a bit of a background of what it means to have a database connector for Prisma that is not in TypeScript, and then sort of dive into some of those questions.
Yeah, that makes sense. Thanks. Yeah, so the Go client initially, like two years ago by now, I think, started like as like an experiment, really, because back then there was, for the Prisma we had back then, there was only the Node.js client, and the problem was obviously that Prisma wanted to have the possibility to expand into different languages, not just different databases, but also different clients or languages. But like all the team was just focusing on Node.js. So the idea was that we wanted to build another client, which is not JavaScript, just like obviously to have that client as well, but also to see if our current tools and structures and all that stuff around it actually works with a non-JavaScript language, because yeah, there are a lot of implications, and we have to see if anything specific like doesn't maybe work in other languages, or and so on. So there's a lot of things we could find out by this, and we did.
And I also imagine that one of the sort of design decisions in Prisma to sort of decouple the Prisma engine that is written in Rust is a big sort of, it's an important decision in allowing multiple clients in different languages, right? Because all of the heavy lifting is still done by the Prisma engine, which is written in Rust. And so a good way to think of these clients, and I'd love to hear what you think about this, Luca, is as like a lightweight sort of wrapper that gives you a lot of this type safety, but still all of the heavy lifting is done by the Prisma engine.
Yeah, so that's a good way to put it. I would maybe say that there are two important parts, one of them being these engines, because they're basically the thing which are used at runtime to actually translate stuff into SQL. But the other part is building the actual client, and that turned out to be really difficult, because the engine, like the engines, they, of course, it's some overhead, and you need to think about how to launch it, and because it's like a side thing which needs to run next to the existing user process and so on. But that's kind of similar in Node.js, and like I think most users agree that this is not a deal breaker, and it's actually quite nice because you can expand easily into other languages. But the bigger, like the second thing turned out to be a problem, which we also like realized with the more we worked on the Go client, is that the internal structures of like the information which we provide to build an actual client, it turns out to be optimized for JavaScript, but really difficult to process for non-JavaScript language, because JavaScript is a really dynamic language, doesn't have any types, and Go does, for example, but not even that, but Go does have strict types, and it doesn't have generics, for example. So that makes it like the perfect language to experiment like a really strict type system where you're really like almost inflexible. So yeah, and that's why I'm curious to hear some input from Robert, because I'm wondering if that also applies to Python, and if yes, like how much, basically. So if you don't have anything else, then I would dive into some technical questions. All right. So Robert, I see that you have built the Python client and looked a bit at the Go implementation. Is that correct?
Yeah.
Doing so. Yeah.
Yeah, but I was inspired a lot by your work. That's basically.
Okay.
I don't think I'd have been able to do it if it wasn't for that, to be honest. Because
Okay,
that's how I
cool.
got into all the internals.
Yeah. Yeah. So like the reason I asked about this is because there are like right now there are two different ways of clients being built, one of them being the JavaScript client, and one of them being the Go client. And the Go client, like you have this AST information, which we call a DMMF. And the initial idea of this piece is that it is like a GraphQL AST, so it contains a flat list of all input types, and they can, like, the list is flat, but they can reference each other. So
Luca, is it okay if we pause here, because in case some of our listeners aren't familiar? So DMMF stands for the Domain Model Meta Format. Is that the right abbreviation?
I think so, yeah.
And essentially, it's an abstract representation of your Prisma schema and all of the possible operations that can be essentially executed in the Prisma engine. So essentially, this is all you need in order, hypothetically, all you need in order to produce a fully working client in TypeScript or in Go or in Python. Of course, the challenges notwithstanding with Python and Go.
Yeah. So that's the idea. But it kind of falls apart with non-JavaScript languages, because the idea was that, like, you have this big flat list of types, and you just, like, oversimplify it, but you map those types one-to-one to the whatever language. So in TypeScript case, it's just TypeScript interfaces. And then you're kind of done. Like, it's really oversimplified, but that's the rough idea. But so in theory, you could do the same thing in Go, but one of the biggest problems is that Go works really differently. So when we would do the same thing in Go, then you would end up with, like, a really verbose and really ugly API, and really inflexible API in terms of when the user wants to run a query, they would need to constantly have some helper methods because of some reason, how Go works and so on. So what we initially decided for the Go client is that we would actually not use all this information and try to map it, but build like a different API, like a completely different API, and just like work around it, which we still do today. And I think the Python client does this as well right now. So I'm wondering if you are aware of this key difference, how the JavaScript client is built and how the Go client is built, and if you think that in Python we could actually maybe use the full DMMF and not hard code anything, and just like map these types one-to-one, basically. Are you following me so far?
Yeah.
Okay.
Yeah, I think
great.
I think that would be. It's definitely more possible than in the Go client, because I've structured the API in a very similar way to the TypeScript API, so that would make it a lot easier.
Okay. So, is there any reason why you didn't do that, and instead like went the Go approach, kind of?
Well, because for one, I have to deal with recursive types, because in Python, if you talk to a Python developer that knows about type checking, they'll know about MyPy, which is a different type checker, and that doesn't support recursive types. So I have to generate pseudo-recursive types, basically, which have a limit to how much recursion there is. And I don't know how well that like sifts with the DMMF. And basically, it was just lots of data, and I didn't really know how to deal with it, so I just hard-coded it. I haven't looked into how it's structured that much, so I don't really know. I have to be perfectly honest.
Okay.
I just decided to go with the hard coding from the get-go to make it easier for myself.
Okay, yeah, that makes sense.
What are some of the downsides of the hard coding? Is this essentially hard coding of what exactly is being hard coded?
So the input types is the difficult thing. So like the part that I'm struggling at with that now is properly supporting combined unique constraints. So when you have a ASAT unique with multiple fields, that currently isn't supported in the Python client, because I've had to do the hard coding, and that's structured very differently than normal unique constraints, if that makes sense.
Yep. Yeah.
and
Because you basically have to do the operations, especially like find unique on 2 fields. You have to provide the 2 values, right?
Yeah.
And what about nested writes? Like, for example, if you want to do an update or create, but then with that also update something or delete or create something else. Is that supported in the Python client right now or not?
Yeah, nested writes are supported.
Okay, so
nested writes are essentially the
Well,
classic example of like you have a user and posts model, and they have a one-to-many relation. You can, within a single query, create a user and multiple posts.
Yeah, that is supported.
Yep. Yeah, but these, you also kind of hard code these nested write operations, right?
Yeah, everything's hard coded basically. I don't rely on any
Okay.
Type structures in the DMMF.
Right. Yeah, that's a bummer, unfortunately. But
Yeah,
it would be interesting maybe to discover like what we could do there, because like a lot of functionality goes obviously missing if we hard code things. Yeah.
I don't know how it would be improved though. To be honest, it's a difficult problem.
Yeah, we're kind of like trying to figure it out passively, like because it's just not like it's not easy to come up with a simple solution, especially not one which works with all languages, because like the current solution works really nicely with JavaScript, but not so much with Go, or probably Java neither. I think Python is a good example because it's really flexible still, and maybe we could do something, but I'm not sure. I'm not a Python developer. Anything else on this topic? Otherwise, I'm gonna. Actually, there's one more thing from that topic. Yeah, basically, you answered my question already, which would have been like. I mean, if you have ideas of how the information could look, or what you would like to see differently, or something, then please share that with us.
Yeah.
Because that is really hard to figure out. And if we have like something which would work with even another language, then it would be great. So maybe I can give a quick example of how I would imagine it. And that is, instead of giving like this huge list of everything you can do and just mapping that, the current idea of how you could do it to build a really nice like Go Client functional API is that instead of giving this flat list of types, we give top level information about parts of the client stuff you can do. So for example, in the Go Client, it would be a query builder part. So because you always query things in the structure of you say model.field.operation. So for example, user.name.equals, right? And that is the query builder API. And then the other part is the actual client. So you do find many .skip or something. And then you can connect those two, like find many, and then in there you can put the query part, like user.name.equals or something. So that would be one idea, to actually expose this information like this in the generator ASD as well. So we could have like the models, their fields, and their respective operations. And then we could give information about, these are the top level queries, like find many, find unique, and then give information for the find unique that it satisfy a unique constraint. So this could be a unique field, but also composite indexes, and then the composite indexes are also listed in there, and so on. So that would be one idea to rework this. And the question then there is, would that work for JavaScript? But it's at least one idea which could maybe work for other languages, especially for ones which have a functional API. Yeah, so if you have any more ideas or suggestions, or what you think could work for Python, then please let us know.
Yeah, I definitely will. I'll have a look in the deeper dive into it and see.
All right.
I'm curious, Robert. I know, Luca, you have some more questions, but I'm curious, Robert, are you using the Python Prisma client already in any existing project or in any project that you're working on?
Yeah, while I was developing it, I started integrating it into a project I was already working on, but I haven't gotten it fully working yet. So I haven't actually used it in a real world example yet.
And has there been sort of any engagement from the Python community in this, or has anyone really showed interest, or is this currently mostly a solo project that you're working on and really trying to get this to a place where it can really be more broadly adopted?
I've had one contributor give me some ideas, and that's been really helpful because I haven't really had any feedback from other Python developers, so I don't really know how anyone else would like it, apart from because this is why I like how I like writing my queries, but I don't know if anyone else likes doing it that way or if any improvements. So.
Right. Got it. Thank you for sharing.
Yeah, I got one more thing. So I'm wondering how you currently use the Prisma CLI. So when you run the Go client, you can actually run a Go command. So Go users don't have to install Node.js because the Prisma CLI is written in Node.js. So what the Go client does, it bundles the Prisma CLI. So when you install the Go client, you automatically have the Prisma CLI. And this way, it's also kind of nice because then the Go client defines the Prisma CLI version so that whatever version your Go client is, it has a compatible packed or bundled Prisma CLI version. That's a bit hacky because, you know, you package like a Node.js binary into a Go binary, but it does work kind of nice, I would say. So I'm wondering if you do the same thing, Robert.
Yeah, it's actually exactly the same thing because I'm
Okay.
I'm just downloading the binary from the same place you get the binary from. So it's
Okay.
it's exactly the same binary.
Yeah.
And it's run alongside.
Yeah. So would you? So what? Like this place where the binaries are currently hosted is kind of like I just did that because I knew that I need it for the Go client. So I guess it would be good for you if that part would actually would actually be like something officially supported by the Prisma team, so that you also get automatic updates in there, so that you can bump this version in your code and so on.
Yeah.
Would that make sense? Yeah.
Yeah.
Okay. Okay. So there's another question which will Daniel which will be asked by Daniel.
And that's related basically. So we spoke about the fact that we have this Prisma engine, and this is a binary that runs as a sidecar along, say, your application process. And one of the major optimizations that we did, at least in the TypeScript and JavaScript client, is that we introduced this a feature we call Node API, which essentially relies on these direct Rust bindings between Node.js and Rust. So what this does is, instead of having the Prisma engine binary run alongside the main application, and the main application essentially communicates with the Prisma engine over HTTP using whatever Unix domain sockets or whatnot. It actually it has some concept of shared memory because you have these direct bindings, and that leads to a lot of performance optimizations. And so I'm curious if that would be also possible in Python. Like, is it possible to use these Rust bindings to directly make calls to the Rust binary, similarly to how Node API works? Or is it right now the main way to do that is to run that as a sidecar binary with HTTP communication between the two?
Yeah, that is possible. I've looked into it, and there are libraries that make Python to Rust bindings very easy and straightforward. But I've never used Rust before. I don't know how it works, so that is something I will look into, and I will definitely get working in the future because it is a big performance improvement, and it's a big like having to make a HTTP request just to get your queries in SQL is a bit.
Yeah. No, it totally makes sense. And I'd love to hear. So, what are your plans now? What's sort of next for the Prisma Python client?
I'm just trying to get it fully like as much functionality as the TypeScript client does, and I'm also looking into different ways of accessing the queries, because in other ORMs you make queries like directly on the objects, if that makes sense.
Right.
So
Yeah.
you'd
Yeah.
say like
An active record style ORMs, you mean?
Yeah, I'm looking into that too, and then that's where I'm going to go in the future, or at least have that as an option as well.
That will be interesting to see.
Yeah. On that note, is there anything else that you would love to share before we wrap up, Robert? Thank you also for sort of coming on and sort of sharing, your experience building this, and really for also having created this. I'm sure that this will really push the landscape of possible clients that use Prisma and sort of bring the benefits of Prisma to more developers. But if you have anything else to add, now is a great moment to do that.
No, I just like to say thank you for having me. It's been lovely meeting you.
It's a pleasure. And a quick reminder, I'm going to also show this on the screen again, that you can find this Python client. These are the docs. And you can also find this on GitHub at Robert Craigie /Prisma-client-py. And so with that, I think we can wrap up. So once again, thank you, Luca, and thank you, Robert. And we hope to see you soon here, Robert, after you've made some progress on it.
Yeah.
All the best.